Learning objectives today are to understand what fire stopping is, understand the importance of fire stopping, recognize the advantages of manufactured systems versus built in place, be able to identify correctly applied systems. Content today, fire stopping defined, the purpose of fire stopping, its importance, how to ensure proper fire stopping. Again, looking at manufactured versus built-in-place systems, the merits and benefits of both. Ideal fire stopping methods. Talk a little bit about updating your specifications if you track fire stopping in your specs, and followed by a brief summary. Starting off with code requirements for fire stopping, most of the major code models or the code bodies, whether it's the uniform code as shown here or the other code models, they all address fire stopping to some degree or another. Prior to 2015, the uniform code really didn't talk about fire stopping at all. It wasn't until that year revision that they replaced the contents of Chapter 14, which used to address fire storm system design, and they've replaced that with fire stopping, and it comes almost verbatim out of the International Building Code language. If you go through Chapter 14 in the Uniform Code and compare it to Chapter 7 in the International Building Code, that's almost word for word the same. International Plumbing Code doesn't really talk about it much except to refer the reader to the International Building Code, which has all of the practices that are currently being adhered to across the nation, across both code areas. I know the Uniform Code is mostly West Coast from the Rockies out. The International Plumbing Code takes up the rest for most of the jurisdictions in the U.S., and that is the predominant code model so far. Fire stopping is a component of a system. A lot of times we think of fire stopping as a product, which is not entirely true. Fire stop products are used to be part of a system. In Underwriter Laboratories, or UL has several categories of fire stopping. For this presentation today, we're going to be talking about through penetrations, which is category XHEZ. So whether it's a through penetration for a vertical assembly, such as a wall, or a horizontal assembly, such as a floor. We'll also discuss a little bit about UL category CLIV, which is for membrane penetrations of electrical outlet boxes. Reading the language of CLIV, it broadly encompasses all outlet boxes, but the language, when you start looking at the UL systems, applies specifically to electrical outlet boxes. Whether or not that will be expanded to include outlet boxes such as ice maker supply, auto washer boxes, and the like, will remain to be seen if it hasn't been already done to date. Fire stopping comprises three elements. You have the rated assembly, such as your wall or floor. You have a fire stop product, whether it's a manufactured device like a sleeve or a collar, or built-in-place systems where backing material is placed if it's required, such as mineral wool, and then a fire caulking compound or intumescent wrap strip. And then you have the penetrating item, such as your plumbing pipe or electrical cables conduit. So all three of those together comprises your fire stopping assembly. These systems are tested per ASTM E814 and UL 1479, which is the standard for fire test of penetration fire stop systems. These standards determine the performance of a fire stop system by exposing the product to be tested to a time temperature test and then followed by a hose stream test. Now, the performance during that time temperature test and the hose stream test is dependent on the types of materials used. For instance, if we're testing a framed wall with gypsum board on it, or if we're testing a concrete slab with cast-in devices or through some type of through penetration system put through it. It's going to depend on the number, type, and size of penetrations. It's also going to be dependent on the material of the floor or wall in which it's installed. The fire stop system testing process in these three photos here is for a framed wall assembly. So on the far left, you have a picture of gypsum board with a penetrating item, appears to be PVC pipe. And around that penetrating item, you have a red fire stop material, which is placed within the annulus of the wall and the penetrating item. And then it's troweled in nice and smooth. Now, the intumescent material here needs to be contained within the annulus. If it's mounted up on the surface of the wall, not within the annular space, it's not going to perform as expected. So that's one of the important features in installing built-in-place fire stop systems, is making sure that that fire stop material is within the annulus of the opening. Once that material is allowed to cure, sometimes it can take 24 to 48 hours, maybe longer if the temperature is lower. It's then placed into, in this case, a wall furnace. And it's going to be subjected to a time temperature test of either 1 hour, 2 hour, 3 hour, or 4 hour burn. Once the time temperature test is complete, that assembly is taken out of the furnace and then subjected to a hose stream test, which the pressure of the hose stream test is going to vary depending on the number of hours we subjected that apparatus to test. So 3 hours and under, it's going to be a 30 psi test, and then anything over that is going to be a 45 psi test. Now, the purpose of the hose stream test is to ensure that once this intumescent material here is burned and charred and expanded, that the water force does not dislodge this charred material from the wall. Now, the reason we don't want that to happen is because if this is still an area that's subject to high temperature and the possibility of fire, maybe the fire is dying down because it's losing its combustion air. If we dislodge that fire stop material, it's going to allow a path for combustion air to enter that chamber and cause the fire to reignite. So the hose stream test ensures that that fire stop material, once it's expanded and charred, does not become dislodged from that opening. For all intents and purposes, this plastic pipe will most likely have burned away. So this intumescent material needs to expand and close off this opening completely so that there's nothing able to get through that. So once all three of these steps are completed and each step is successfully passed, the product then, or that assembly then gets a UL listing. And we'll talk a little bit more about that. Purpose of fire stopping is intended to restore the hourly rating of fire resistive assemblies breached by penetrating plumbing, electrical, and mechanical installations. It increases the availability of escape routes for occupants of a building, giving them the time or means of egress to get out of the building. So on this line drawing here on the right, we can see we've got office cubicles along the corridor that's delineated with this red escape line. This is your escape routes here. So all the walls along this corridor would either be a 1 or 2 hour rating or more, depending on the type of occupancy and the number of occupants within that area. 1 and 2 hours is typical, but if we're talking about a retirement home or a healthcare facility, it may be a 3 hour rating wall, and sometimes it can be a 4 hour rating wall. Again, to give the occupants in that particular structure time to get out. Fire stop systems must be installed exactly according to listing details. Failure to install exactly according to listing details will result in a system that will not perform. So on the first slide we looked at, we had the 3 steps of the fire stop system to be tested. We saw that was nicely, neatly placed and troweled, then subjected to a burn. In this case here on the bottom left, we see that that's not at all what's happened. We see the intumescent material mounted up on the surface of the floor, piled up around these cables. In addition to that, we've got what looks like a concrete blank from when they cored the hole being used as part of the fill material. Now, this is never going to be something that UL will ever approve. The construction debris is never regarded as part of a UL system for fire stopping. So right away, you know, if I'm an inspector walking this project and I'm looking for fire stop installations, and I saw something like this, I probably would, if I saw any more than this, I would probably shut the whole thing down and tell them to start over and submit on it. Obviously, nothing was submitted here because this is not something you'd see in a submittal. On the right, we see a couple of penetrations being subject to a burn test, and this is from this is a screen grab from a video that UL has on their website that demonstrates properly installed UL systems versus systems that are not listed, and they're using materials that are not approved for fire stopping. So in the foreground, you can see that the makeshift or field devised method did not successfully keep the fire from penetrating and breaching that opening. In the background, we can see that the intumescent material, the red bead, is starting to swell and expand and seal off the annular space between the pipe and the opening, and it's doing its job. It's preventing the smoke and hot gas from breaching and entering that compartment. So compare and contrast in the foreground, a makeshift method, and in the background, a properly installed UL assembly. Consequences of fires, and this is from the NFPA fire loss statistics in 2018. We can see that they can be devastating. Fire departments respond to a fire about every 24 seconds. Annual direct property loss is in excess of 25 billion. Again, this is for 2018. And then annual civilian casualties is 3,000 plus lives lost, which also includes wildfires. One globally applied principle for fire safety is compartmentation, and that's segmenting the building or comparting it off so that you have compartments where if you do have a fire breakout, we can contain it more efficiently and more easily by creating these areas, around that fire chamber with rated assemblies. So you have your floor and ceiling assemblies, which are going to have a 1 or 2 hour rating, and then you have your wall assemblies around it, again, 1 or 2 hour ratings. And that will help slow the spread of fire, giving people on that or in that building time to get out before it's fully engulfed. Fire walls, fire floors are two of those methods for a lot of the construction we see today. Types of fire, smoke, and wall assemblies are listed here. We have fire walls, fire barrier walls, shaft walls, fire partitions, smoke barriers, and smoke partitions. And we'll describe each of these in turn. So a firewall is fire resistance rated. It extends continuously from the foundation to or through the roof and has sufficient structural stability so that if the building were to collapse on either side of it, the wall would remain standing. You might see something like this between existing construction and the addition of a new wing or part of the building that's going to be added on to this. You might see this in a hospital or in a type of building that's designated as a secure facility. Fire barriers, wall assembly that restricts the spread of fire, must span from floor to ceiling to the underside of a floor or roof above, does not need to be continuous from story to story, and does not require structural independence from the building. So this would be a typical wall partition between office spaces or living spaces within a apartment building or a hotel. And then the wood composite floor ceiling system, subfloors you see pictured here. The assembly is such that we've got our wood frame, our combustible material, and it's wrapped in gypsum board on the underside, and then we have a subfloor, sometimes lightweight concrete or some other fire-resistant material over the top of it so that it's fully encased. Typically 1 hour resistance, underside of floor or slab, and then underside of fire resistance rated as floor ceiling and roof ceiling assembly. Now we're going to explore this one a little bit more because there were some changes in the International Building Code about how that was constructed. So prior to 2012, the way the code was written was that the underside of the wood joists need to be continuously wrapped across the top of the bearing walls underneath. Now, that's not the way things happen in the field. In my experience as a plumber in the field, we never saw the drywall contractor out wrapping the underside of wood joists prior to being placed on top of the bearing walls. More typically, what would happen is the framing contractor would be out there. They would be erecting the walls, setting the joists, and then building it up to a point where the drywall contractor could then come in and begin wrapping the underside of the joists and the bearing walls, as you see on the right here. Well, prior to 2012, there was no variance allowed. It was simply up to the individual authorities having jurisdiction to make the call as to whether or not they would require the contractor to go back and wrap it underneath continuous as the code read, or to allow them to do it the way they've done it for years. From a practical application standpoint, this doesn't make any sense, because if I'm wrapping the bottom side of my joist before the building is dried in with drywall, and this stuff gets wet, I've got to tear it out and start over again. So it's not something that makes any sense from a practical application standpoint. So in 2012, International Building Code revised the language to reflect what was being done in the field, and that is how we're continuing to do it today. Areas that can allow for fire smoke spread within a typical structure. And these sometimes come along during construction. More often than not, some of these come along after construction is completed and the owner is occupying the building. For instance, your data cables, low voltage cables, sometimes changes are made to the building occupancy where they need to add additional cables and routing and whatnot. So you're going to have penetrations made through rated assemblies without the benefit of a final inspection being done. And unless the contractor secures a permit to get the work done and then has an inspector come in and review the work once completed, again, looking for these areas where penetrations to rated assemblies might not have been treated properly. That's a problem that exists today. Membrane or one-sided penetrations, whether it's serving electrical equipment as we see here, or if a plumbing fixture was added and we have membrane penetrations with water and waste piping to serve that fixture. Again, those are all areas that must be inspected and treated for fire safety if that is a rated assembly that was penetrated. Other areas, gaps at the edge of the slab. If a door is cut into a rated assembly and it's done after the fact, after construction has begun and it's maybe a change in plans, if this is a rated assembly, does the door match the rating? Unsealed pipe and penetrations for ductwork. Again, sometimes work takes place after the building owner has occupied the structure, and whether or not that work is permitted or inspected and done correctly. Again, these can be problem areas that arise after the fact and must be addressed. Identifying incorrect fire stop installations. Sample of deficiencies found in incorrect fire stopping, and this is something that happens across the industry, across the country. On almost every project, we're going to see problems with the fire stopping installation. Again, whether it's poor education on the part of the installers, they weren't trained properly by the factory or the manufacturer of the product they're using, or they forgot, or maybe there was a change out of the crew, and the crew that was trained is no longer there and they have someone else taking their place. All of these things can contribute to the list of problems, and this is a very modest list to be sure. But some of the more common things we see are preparation of the joint. In other words, was the area around it cleaned? Was the debris removed? Is it dry? Is it ready to be have fire stop material installed? Work only partially complete. Did they put the backer in and somebody else was supposed to come along and put the fire stop sealant in, and that step didn't happen? Another more common is no design listing submitted or installed. A lot of times you have folks with the idea that if I just buy a tube of fire stop compound and simply put it in the annular space around the penetrating item or around it on the surface of the wall, it should be good. But without knowing whether or not the fire stop material they're using is rated for that assembly, or whether they're using enough or the correct product is unknown, because they're not following a UL system. Design listing not followed. They might have submitted on a plan, but they're not following it. Another one that's common is product that's expired, frozen, ruined by excessive heat, or washed out. It doesn't take much, because the products that are on the market today are fairly robust, but they are susceptible, especially to high heat during the summertime. If you've got a job site down in the Southwest of the United States or somewhere else where it's nice and warm during the summer, and you have these storage containers on the job site that can easily exceed 120 degrees Fahrenheit inside during the summer, a lot of the fire stop sealants are sensitive to high temperature. And it'll say specifically on the containers not to be stored above a certain temperature. 120 degrees is usually the upper end limit. And if it reaches that, or it's allowed to sit in there for that length of time, what happens is that fire stop sealant begins to set up and cure inside the tube. So it becomes unusable at that point. Product expired is another common one. Most of the fire stop sealants on the market today have about a 3-year shelf life. So if you've got something that's been sitting around for a while, stock's not rotated, or they bought too much on one job and it's more than time as goes by to get to the next job before time runs out on the product, it can be a problem. If it's installed before it's allowed to dry, in other words, if the project got wet and the floors and walls are wet, and they try to put that stuff in there in that condition, it won't cure completely and it'll be ineffective. Broken seals, especially if you're going on a job site and you're looking around fire stop material that's been installed and you see it starting to crack and break away from the wall or from the penetrating item, that can be a problem. Installed systems differ from what was submitted. Again, it happens occasionally. Installer qualifications not meeting specification requirements. Sometimes you're going to see standards and specifications that require installers to meet certain levels of qualifications, and if they're not, and the persons doing the job are not certified or qualified, who's to say that they're doing it correctly? No fasteners or incorrect fasteners installed, especially for collars. Installers not familiar with the code requirements. And then last but not least is sealant not applied properly or consistently. So all of that in mind, this is something that our fire stop inspectors and our manufacturers doing job site walks need to keep in mind as they're looking at these systems that are installed and judging whether or not they're done correctly. What's going to drive this is going to be the UL system. And this is going to be manufacturer specific. So if I'm using product X, the UL system I'm following is going to be specifically for that product. It's not going to be for some other product on the market. And if that's the case, if they're using one product and the UL system says they're to be using another, right away we've got a problem. The Underwriter Laboratory has a nice nomenclature key here that helps us understand what these UL systems are all about. In the past, we see the system number up here that's a C-AJ-2842. For a lot of years, I didn't understand what these were or how to read them or what they meant, and I relied almost entirely on the line drawing below to give me an idea of what kind of system I'm going to be using, what kind of construction am I going to be dealing with, and then in the description below that, steps 1 through 5 or 6, to tell me how much I need to put in, what type of material, and so on and so forth. But if I'm aware of what this alphanumeric system is, it helps me understand better whether or not I've got the right UL system to begin with. So C-AJ-2842, what does that mean? So the C, starting over here on the far left, is for floors or walls. So that UL system we just looked at is for either a floor or wall combination. Now the next 2 letters, the A and the J, A is for concrete floors 5 inches thick or less, and J is for concrete or masonry walls and 8 inches thick or less. And then the last 4 numbers began with the 2. The 3 numbers following that first number are specific to the manufacturer of the product I'm using, but this first number, the 2, is going to be critical because that tells me it's a non-metallic pipe or conduit that is the penetrating item. So if I'm looking at that prior UL system and I see it submitted for something different, I can tell right away that it's not the right system because this information here tells me what that UL system is rated for. So taking this and applying it in real life, we have system number up here, W-J-1310. Now, going back to our nomenclature, W is for walls. Remember, the J is for concrete. And the first letter of the last 4 began with the 1, so it's a metal pipe, conduit, or tubing. So right away, we can see we've got the right UL system based on the application in the field. It's a block wall. Our F rating is 2 hours. And the rating, or the UL system I'm following, has a rating of 4 hours. Is that good or is that bad? Because remember, we were saying that we have to match exactly according to listing details. Well, in this case here, our rating on the UL system exceeds the rating on the wall. So whatever we're going to be doing is going to be more than enough. So in this application, having a higher rating on the UL system versus the assembly we're dealing with simply means we're going to be using more intumescent material than is needed. So that will be acceptable. So steel conduit is 2-inch through penetrant conduit, nominal 4-inch or smaller. So we're good there. Annular space, minimum point of contact on the top. So up here we see that the top of the conduit is touching the annular space inside that opening. And then below, the opening is not to exceed 3/8 inch. So from here to the edge of the opening of the wall is 3/8 inch or less. So this area here that's outlined in red basically says the exact same thing. We have 0 point of contact to a maximum of 3/8 inch. And then the fill the void or cavity, probably not able to see it from your end because it's really small, but it says that I need to put a minimum 1/4 inch thick diameter bead of caulk applied to the point where the conduit contacts the wall, and then a 1/4 inch depth or minimum 1 inch depth of fill in the annular space around it. So as an inspector, if I'm walking the job and I see this finished like this and I'm looking at this UL system, the only thing I can't tell for certain is how much material they used on the fire stop sealant. So I'd have to cut in to this a little bit, just enough to see whether or not they did get that 1 inch depth of sealant. If they did, give them kudos for doing a good job, but then they need to refill that with some more sealant. So certain amount of my inspections are going to require some type of destructive testing on the project, depending on the type of project and the occupancy level of that project. And we'll see a little bit more about that down the road here. So for all intents and purposes, they did a good job of matching up the UL system with the condition in the field and followed the directions exactly. We're going to assume these got his 1 inch thick sealant in here per the UL system. And then we can rest assured that they did a good job installing this. On the other hand, we see something like this where they've simply, they've got, looks like more than one trade involved putting in low voltage and electrical cables through this opening, and the fire stop installer simply mounted up all of this red sealant on the surface of the wall around the cables and penetrating items. And first thing I'd ask is, where's the UL system you followed for this installation? Chances are they're not going to be able to give me one. The other problem is that with all this intumescent material piled up on the face of the wall like this, if this were to start to heat up, once it's exposed to heat and temperature or fire, this is going to start to expand. And since there's nothing to contain it, it's going to expand outward away from the cable, which means we're not going to get that sealing effect that we want from the expansion. So what we want to look for is a UL system like this that talks about multiple penetrations through an assembly, whether it's nice and neat and organized like it's shown in the picture on the right, or if everybody just bundled together and tried to fit as much as they could into that one spot and then put material around it, hoping that it would work. This case here, it looks like it would take some kind of an engineering judgment to look at this, look at the reading of the wall, and then how are we going to clean this up so that it's acceptable as a fire stop system. Annular space, to better understand minimum max on the annular space. If the penetrating item is placed concentrically within the opening, your min-max is going to be the same. But more often than not, the holes are drilled or cut into the opening or into the assemblies we're trying to penetrate, and then the items are installed, sometimes eccentrically as shown here. So that's where your min-max is going to come in. There's going to be a minimum amount of space required. A lot of times it can be point of contact. In other words, the penetrating item is touching the side of the opening. So we have 0 on your minimum, and then maximum would be whatever the UL system designates for that fire stop assembly. So in this, looking at it from a horizontal view, you've got your backer material, which in this case is a mineral wool, which is just stuffed into the opening to provide backing for the fire stop material. And then the fire stop material is then placed in the annular space to the depth required by the UL system we're following, and then troweled nicely within the annular space so that we don't have it all mounted up on the outside here. When it's mounted up like that, it's not going to do any good in the event of a fire. We want the wall and the floor to act as a container for that fire stop material to force it to expand inward if this penetrating item were to burn away. Here's another one on the top right or top left here. Looks like an opening was cut into the block wall that was larger than needed for the material or the penetrating items going through. So rather than fill up that big opening with fire stop material, they came along and patched it with drywall. Looks like one layer of drywall. We're going to assume it's 5/8 type X, which is your 1 hour rated drywall. And then all your seams and cracks and contact points are sealed up with fire stop sealant. Now, if this is something that was done per UL or an engineering judgment, that's fine. We would need to see the documentation to verify that it was done correctly. But absent any documentation, the problem we have right away is that typically block walls are 2 to 4 hour rated, and putting one layer of drywall reduces that to 1 hour. So if this is a 1 hour wall, that's fine. If it's not a 1 hour wall and they're patching it with 1 hour drywall, that's a problem. So we need to get this corrected. And engineering judgment is typically the solution for that. Another one here, bottom right, where we have a penetrating item going through an opening in the deck that's a lot larger than the penetrant, as well as the fire stop collar. So we can see that this isn't going to do any good at all in the event of a fire because the opening behind it has no restriction, and we've got an opening that's unprotected. Here we have another example of a what looks like a properly done fire stop system installation. We've got the penetrating item. We've got the fire stop material. Looks like it was done concentrically within the hole. So we have our fire stop material troweled neatly within the opening of the annular space. And the only thing we would again need to check is, what UL system did we follow? Did we apply the right amount of fire stop material? And other than that, it looks great. The other thing that has come up that is it's not required by code as of yet. I know that's gone back and forth, and it's not even required by UL. It's best practices is to label all your fire stop penetrations in those areas that are exposed to view or access. So, along corridors and areas where maybe the building systems engineer would come in and do maintenance or upgrades, we need to label our fire stop assemblies so that if this is disturbed or damaged in any way during the course of remodel or repair, they have the UL system that was followed, they have the material that was used, and they can go back and repair that fire stop system if it's damaged to what it should be. So going in and understanding the ratings that we see on the UL systems, the first one is the F rating or the fire rating. This is your test per UL 1479. It's a mandatory test. It measures the amount of time the fire stop system will prevent the spread of flame. So we have 1, 2, 3, and 4 hour rating. F rating is the measure of escape time for building occupants. So this is the one we're going to see more consistently. The L rating, you can think of that as the leakage rating. Again, this is an optional test per UL 1479, and this measures the amount of air leakage through the fire stop system. So imagine you've got a fire chamber with a fire in it on the floor below, and you've got the air expanding in that fire chamber. What's going to happen is the air, as it's expanding, is going to look for a path of least resistance, a way to escape out of that combustion chamber. And it's going to go through anything and everything, whether it's around doors, windows, or penetrations made within the floor or walls. And that's what we want to control. We don't want that hot air or cold smoke, as it's sometimes referred to escape into other parts of the building. So we want to contain that as much as possible. So if we have fire stop systems that are installed, having an L rating means that it will give us an idea of how well it will resist that pressure to allow the hot air and gases to escape from that chamber. and it's measured in cubic feet per minute. The lower the number, the better the L rating. The T rating, this is one that comes up quite a bit, mostly due to lack of understanding, a proper understanding of when the T rating is applied. Measures the amount of time for the surface of the penetrating item on the non-fire side to reach 325 degrees Fahrenheit above ambient temperature. So on this line drawing here, what we see with the insulation wrapped around it in stages on the upper side of that floor, if we have a fire going on down below in the temperature, we're going to assume this is a metallic pipe of some sort. The pipe is heating up and it's getting hotter, and it's getting hot enough so that the temperature of the pipe reaches 325 degrees above the ambient temperature of the space above it. You know, if they're 70 degrees on the upper side within that occupied space or unoccupied space, and we add another 375 degrees to that, we're now beyond the point when paper or cotton can combust if it were to fall against that pipe surface. So if this is outside of a wall, then we need to insulate it so that anything that might fall against it doesn't ignite and catch fire. Now, if this pipe were coming up within a wall, whether the wall is rated or not, the T rating does not apply. That's the thing right here. It says for penetrates located outside of a wall assembly above or below the fire chamber. And again, the T rating is achieved by covering the penetrant with fire-rated insulation according to appropriate UL system. T rating exceptions. 2009 International Building Code, floor penetrations contained and located within the cavity of a wall above the floor or below the floor do not require a T rating. So this is where we run into questions a lot of times, because they see a pipe coming up and they assume that it has to have a T rating. Well, if it's contained within a wall, whether it's rated or not, the T rating does not apply. And then in 2012, another amendment, floor penetrations by floor drains, tub drains, or shower drains contained and located within the concealed space of the horizontal assembly do not require the T rating. So in this case here, since the horizontal assembly is part of the concrete floor, and then you're going to have a drop ceiling below that, in most cases, again, depending on the authority having jurisdiction, how they interpret that drop ceiling then becomes part of the horizontal assembly. If that's the case and that's how it's accepted, then these pipes here don't need to meet the T rating. Another T rating exception in 2015 is for switchgears or conduit serving a switchgear, 4-inch diameter and smaller. Again, on the underside or upper side of this, depending on how it's routed, that conduit does not need to be concealed per the T rating. Again, we don't want to wrap up conduit that's generating heat or subject to heat rise from electrical loads to be insulated, because then it's got no way to dissipate the heat, and that in and of itself could be a cause for fire. So conduit serving a switchgear does not need to be T rated. The W rating, this is another one that we see more often. It's fire stop system's ability to protect against water leakage. Now, the way UL measures this and tests for it is, you can see it here in the picture. They have the test slab cast with the cast-in device, again, whether it's a built-in place system or it's a manufactured assembly. Then the penetrating item, we can see on the underside of the slab here, it looks like copper tube that got installed through that. It's going to be pushed up through that fire stop assembly all the way so that the top of that penetrating item is in excess of 36 inches above the slab. Once that's done, then we have these transparent cylinders that are sealed to the deck around that fire stop system and penetrating item. And then it's filled with a colored fluid up to 36 inches. We can see that done in the two cylinders in the background and then the two in the foreground. Once those cylinders are filled with the colored liquid, it's going to allow it to sit for 72 hours. If during that time none of that colored fluid makes its way through that test slab and then onto the paper below, it gets the ULW rating. So that's how they measure the ULW rating for fire resistant assemblies to restrict flow of water. And that will show up on the UL systems, whether or not that fire stop system has that W rating. In this case here, it's class 1, and it refers the reader to item number 5 as to what conditions must be met to achieve that rating. Couple definitions: intumescent versus elastomeric. Fire protective products fall into 2 categories of either intumescent or elastomeric. The intumescent products swell, char, or otherwise expand when subjected to a specified degree of heat. Different materials have different degrees at which they begin to intumesce or expand. These are like your wrap strips, your sealants, your caulks, your collars, all of those items that are part of that family of products. And then your elastomeric products, if you were to look inside a cast-in device from a variety of manufacturers, you'd probably see some type of rubber diaphragm inside that goes around the penetrating item. That's going to be your smoke seal, and in some cases your smoke and water seal. That's going to allow the fire stop product or device to prevent the spread of smoke and gases until the intumescent material or collar around that heats up enough to completely seal off that opening. Here's a 3-picture example from UL of what their intumescent material looks like when it's tested. In this case here, we have a single layer of wrap strip placed within the annular space of this opening. It's then heated. As you can see, it begins to expand and fill up the opening. And then the full expansion is going to close off the opening almost completely. Again, with a single layer wrap strip, we've got an almost complete closure in this opening. If we added 2 layers of that wrap strip, it would have closed it off completely. So the stuff expands quite a bit when it's heated. Moving on to fire stop submittals, suggested content. Now this is what the contractor is going to submit on at least fire stop. The installer of the fire stop system should provide a cover sheet with the project name, location, company name, and location. There should be a table of contents, in other words, what fire stop systems we have. Product information sheets, whether it's SDS or MSDSs or application or storage information. Shop drawings, these are part of what the UL systems are going to comprise. Material safety data sheets, certificates of compliance, product test reports, and installer qualifications if required. So when you get this stuff from the contractor, you're going to have your product data sheets. It's going to have information about the product, storage, handling, what its expiration dates are, or what its warranties are. And then in addition to that, you're going to have your UL listed assemblies, which includes the shop drawings, and then any ratings that are applicable for that application. Engineering judgment solutions, when and why are they used? The best answer is that if you have a situation in the field for which no UL listed system exists, that exactly matches the conditions of the application, then we are looking at the need for engineering judgment. These happen quite typically across the industry and with almost every manufacturer. And it's going to be dependent on how robust the UL libraries are for the manufacturers of the fire stop products we're using. If we're using a product that's fairly new to the market and the manufacturer doesn't have a lot of UL systems because they haven't had the opportunity to design and test UL systems, then we're probably going to be looking at engineering judgments more often. If you have a manufacturer of product that's been in business for quite a number of years and they've got a very robust library of UL systems based on tests that they've designed and conducted, then we probably are going to have not as many UL judgments. So it's all going to come down to what's available for the product we're using. Anyway, but the typical applications with an engineering judgment would be reused, again, is if the situation in the field does not exactly match the conditions or the UL system that we're using. A couple pictures here of examples that we've got irregular shaped holes. We've got stuff that's done in the field, probably chiseled through the concrete here rather than cutting a nice clean hole. We're not going to see a UL system that's going to have this outlined as a tested UL assembly, so they're probably going to need to get something from an engineering judgment engineer to give them the solution that will work in that application. Engineering judgments cannot be used in lieu of available tested systems. So if we have something in our library that satisfies the need for the project in question, but the contractor doesn't want to use it because there's a cost associated with the materials required or what have you, we're not going to issue an engineering judgment to alleviate that. They need to follow what's been subjected to burn test and proven to be useful. Must be issued by qualified technical personnel, not the salespeople, not the rep. It's got to be done by the fire stop engineer for the that works for the manufacturer, either or UL, based upon previously tested systems. In other words, it's got to be something that the fire stop engineer is drawing from, where the systems were actually tested in a burn test, and not something that they're contriving based on prior experience or knowledge. Be issued only for a single job, location, and application. This has come up occasionally where they've gone from one job to the next. The situations are similar and they've run into the same situation, but now instead of asking for a new engineering judgment, we're going to use this one from a prior job. We can't do that. Engineering judgments are based on the assumption that the recommended system would pass if tested for the required rated period of time. The engineering judgment are provided free by the manufacturers of the products that they're using. Turnaround time is typically 2 to 3 business days, sometimes sooner, sometimes longer, again, depending on how busy they get. But that's the expectation. Remember we said something about identification and labeling early on in the presentation, that it's not a code requirement as of yet, and it's not something that's specifically required by UL. However, it is recommended as a best practice so that in the event that a fire stop system becomes disturbed or damaged during a building renovation or remodel, that sticker that can then alert them as to what UL system is in place there and how to repair it. Last but not least, third-party inspection of fire stopping. Fire stop special inspection is mandated for high rises in risk category 3 and 4 buildings, and that's per International Building Code 2012, section 1705.16. So if you're designing a project and we have buildings and it happens to be a building that falls into one of these categories, we need to have a special inspector there that is focused solely on fire stopping. So risk category 3 buildings, examples would be elementary schools with greater than 250 occupants, or public assemblies with greater than 300 occupants. Risk category 4 buildings, such as your medical facilities, and buildings containing highly toxic materials that may endanger the public. So these types of buildings require the services of a special inspector to make sure that our fire stop systems for all categories are being done correctly and installed properly. And there are standards that third-party inspectors must meet. The ASTM E2174 standard practice of on-site inspection requires that that the inspector witness at least 10% of the installations and then perform destructive testing on 2%. And then on ASTM E2393 standard practice for inspection of installed fire-resistant joint perimeter fire barriers, they need to witness at least 5% of the total installation. And then destructive assembly or visual inspection is appropriate, with 1 sampling per type of joint system every 500 lineal feet. So it does spell out fairly clearly what these inspectors need to do in order to make sure that the fire stop systems are installed correctly. And that brings us to the end of our presentation. Are there any questions?
I don't see anything that popped up, Jim. You got any questions? We can open it up. Yeah. Okay. Well, thank you, Jim. That was a great presentation. And thank you all for joining us today and for supporting DMAU throughout 2023. Stay tuned because we will have a new class schedule out for 2024. Just check our social media networks and website. Thanks again, Jim, and thanks again, everybody. and I hope you all have a good Merry Christmas.
Thank you, and Merry Christmas to all.